Hello friends, myself Subhash Nagarse from Sri Digambar Jain Gurukul High School, Solapur. I shall welcome to all of you in this session of 10th Standard Science and Technology Part 1st. The topic is chemical reactions and equations. Friends, in this chemical reactions and equations part 1st, you must have to recall the things that you have learned in the previous standard. I think you might have learned this chemical reaction and the chemical equations little bit in the previous years. In this session, we are going to discuss on the following important subtopics, and those topics are chemical reactions, chemical equations, writing a chemical equation. Let us start with this chemical reaction. So friends, before going to start with the definition of this chemical reaction, we must have to recall some things. What are the types of molecules of elements and compounds? That we must know. Friends, the molecules of an element are made of one or more atoms that are exactly alike, whereas the molecules of compound are made up of atoms of different types. The second question is that what is meant by valency of elements? Friends, the capacity of an element to combine is called its valency. The capacity of an element to combine is called its valency. It is the number of chemical bonds formed by one atom of an element with other atoms. The third question that we have to recall is what is the requirement for writing molecular formula of different compounds? How are this molecular formula of the compounds written? Friends, the requirement for writing this molecular formula of compounds are the symbols of the radical along with their charge, that is valency. The steps for writing the molecular formula of a compound will be: number 1, writing the symbol of the radicals with a basic radical on the left side and acidic radical on the right. Writing the valency below the respective radicals. Third, cross multiplying the valencies to get the molecular formula of the compounds. And the next is the number of radicals is indicated by using appropriate subscripts in the molecular formula. So friends, I think you might come to know in earlier standards we have seen how compounds are formed by chemical combinations of the elements. We have also learned that the driving force behind this formation of a chemical bond is to attain an electron configuration with a complete octet. The atoms attain a complete octet by giving, taking or sharing of electrons with each other. Now chemical reactions, that is very important. So some of the scientists of the 18th and 19th century carried out fundamental experiments of these chemical reactions. They proved from their experiments that during the chemical reactions, the composition of the matter changes and that change remains permanent. On the contrary, during the chemical change, only the state of matter changes, and this changes is often temporary. Following is one of the table. From that you have to identify which is the physical and chemical changes. So here you could see a table wherein the phenomena that we are going to consider, and that is which is that one, whether physical or chemical. Friends, here first is the transformation of ice into water. This is the physical change. Second, cooking of food. It is a chemical change. Then refining of fruit. That is a chemical change. Milk turned into curd. That is again chemical change. Evaporation of water. That is a physical change. Digestion of food in stomach. That is chemical change. Size reduction of naphtha balls exposed to air, that is chemical change. Staining of shahabadi or kadappa tiles by lemon juice is again chemical change. breaking of glass object on falling from a height. That is again, you could say this is a physical change actually, but broken, it is molten, can be prepared. But it is also becomes, if some constituent are there with this, that will form a chemical change. So friends, now we will see the next point, that is an experiment, an activity we can say. With the help of the teacher, you should have to try for this. The apparatus required here are thermometer, this evaporating dish, tripod, stand, funnel, Bunsen burner, and so on. Chemicals that required are limestone powder, copper sulfate, calcium chloride, potassium chromate, zinc dust, sodium carbonate, then phthalic anhydride, etc. You should have to carry out these activities that we are going to discuss now, 1 to 5. Read the record temperatures and activities and fill the table. Observation table you have to complete. Friends, here some 5 activities are there. Out of this, first is take a spoonful of lime stone powder in an evaporating dish. Heat it strongly on a high blue flame. What happens here? This limestone is the CaCO3. When the CaCO3 is heated, it gives you CaO plus CO2. Means in this case, the color change, there is no color change. Gas released, yes, carbon dioxide gas is released, CO2, and temperature change is no. And the nature of this chemical, or it is a chemical change, certainly. The second activity we are going to consider is add zinc dust into the copper sulfate, CuSO4 solution. Means CuSO4 plus Zn gives you ZnSO4 plus Cu. Means from copper sulfate and this zinc dust, there is a reaction, displacement reaction occurs here. SO4 sulfate group attached to the zinc, ZnSO4 formed copper is released. So here again, here blue to colorless, it will become ZnSO4. Gas release, no gas release, temperature will be increasing. It is a chemical change. Third one activity that we are going to do is add a potassium chromate solution to barium sulfate solution. Potassium chromate K2CrO4 and barium sulfate is BaSO4 solution. When you get write the balanced equation, that will be BaSO4 plus K2CrO4. Here BaCrO4 precipitate is formed and K2SO4 is forming. So here again you will see that here yellow precipitate of this barium dichromate is forming. No gas is released, no temperature changes, chemical reaction this one. Fourth activity is add sodium carbonate Na2CO3 solution to the calcium chloride CaCl2 solution. The reaction that will be CaCl2 plus Na2CO3, that gives you 2NaCl plus CaCO3. Friends, here you could see this yellow precipitate is forming. Then no gas is released, temperature will increase, and this is a chemical change. Here again you could see this color change in the fifth. This phthalic anhydride in this evaporating dish we take, there is no change in the color, gas released, yeah, and it is a physical change. Close the end of this stem to this funnel with a strong cotton plug. Keep this funnel inverted in the evaporating dish. For each and every reactions that we are going to be considering 5 different activities. So records are, you could see here. Now again, one thing we can observe here, that in this reaction, physical change and chemical changes, some daily examples we are going to face and list them. So what is this physical change? A physical change takes place due to the changes in the parameters such as temperature or pressure. Often a physical change is reversible. The composition of this matter remains the same in the physical change. For example, ice is transformed into water on heating and water is transformed into ice on cooling. On the contrary, if the composition of matter changes during a process, then it is called a chemical change. When we call a particular progress or phenomena as a chemical change, some chemical reactions are taking place in the concerned matter. So, you can say that chemical reaction is a process in which some substances undergo bond breaking and are transformed into new substances by forming a new bond. The substances taking part in chemical reactions are called reactants, whereas the substances formed as a result of the chemical reaction by formation of new bonds are called products. For example, formation of carbon dioxide gas by combustion of coal in air is a chemical reaction. In this reaction, of coal, that is a carbon and oxygen from the air, are the reactants, while carbon dioxide is the product. A chemical reaction is represented by writing a chemical equation. So friends, what is this chemical equations? Let us first look at a chemical reaction in the activity 2 that we have just saw. A colorless solution of zinc sulfate is formed, addition zinc dust to the blue solution of this copper sulfate. So the chemical reaction here taking place will be aqueous solution of this copper sulfate plus zinc dust that gives you aqueous solution of zinc sulfate plus copper. So equation 1. This simple way of representing a chemical reaction in words is called a word equation. So this is a word equation here. Equation 1. A word equation can be written further condensed form by using a chemical formula. This copper sulfate can be written as CvSO4 and zinc dust is Zn. For new product form, that is a solution of zinc sulfate, that could be written as ZnSO4 and this copper is Cu. So the representation of this chemical reaction in a condensed form using a chemical formula is called the chemical equation. In the above equation, copper sulfate and zinc are reactants. They react with each other to form a copper particles and a solution of this colorless zinc sulfate as a product having totally different properties. The ionic bond in the reaction, this reactant side, CvSO4 breaks and the ionic bond in the product ZnSO4 is formed during this reaction. So friends, now what is writing a chemical equation? Let us now see conventions followed while writing a chemical reactions. The ways on the left hand side there are reactants and on the right hand side there are products. So in a chemical reaction, the reactants are written on the left hand side while the products are on the right hand side. An arrow heading towards the product is drawn in between them. This arrow indicates the direction of the reaction. If the reactants or the products are two or more, they are linked with the plus sign in between them. For example, in equation 2, a plus sign is drawn in between the reactant CvSO4 and that of Zn. Similarly, a plus sign is drawn in between the products of ZnSO4 and Cu in the previous reaction. To make a chemical equation more informative, the physical states of the reactants are indicated in the equation. Their gaseous, liquid and solid states are indicated by writing G, L and S respectively in the brackets. Moreover, if the product is gaseous instead of G, it can be shown with the upward arrow pointing upward. If the product so form is insoluble solid in the form of precipitate, then it is instead writing S, it should be shown with a downward arrow pointing downwarding. When the reactants and products are in the form of a solution in water, they are said to be present in aqueous solution state. The state is indicated by putting the letters AQ in the brackets indicating aqueous solution. So here equation 2 we can be written as, that is CvSO4 in the aqueous state plus Zn in solid state gives you ZnSO4 in the aqueous state plus Cu in the solid state. Equation 3. When heat is to be given from the outside to bring about a reaction, it is indicated by the sign delta. You can see the triangular sign over the arrow. that indicates the direction of the reaction. For example, the reaction in which the slaked lime is formed on heating limestone is given as CaSO3 in the solid state, that is limestone. This triangular indicates the heat provision. CaO, that is the slaked lime, is formed plus CO2 in the gaseous form. Fourth equation. Similarly, the fact that heat is released during the reaction between the aqueous solution of copper sulfate and zinc dust is indicated as, here it could be seen as CuSO4 in the aqueous state plus Zn in the solid state, that gives you ZnSO4 in the aqueous state plus Cu in the solid state plus heat. Fifth equation. Friends, it is necessary to fulfill certain conditions like specific temperature, pressure, catalyst, etc. to bring about some reactions. So the conditions are indicated below or above the arrow, indicating the direction of the reaction. For example, the reaction of a vegetable oil takes place at a temperature of about 60 degrees Celsius with hydrogen gas in presence of this nickel as a catalyst, and could be written as vegetable oil plus this hydrogen in the gaseous form at 60-degree temperature and nickel as a catalyst. It gives you vanaspati ghee in a solid state. This is the sixth equation. Special information of names of reactants or the products are written below their formula. For example, copper in reaction with concentrated nitric acid gives a reddish colored poisonous nitrogen dioxide gas. It could be explained like this: C in the solid state plus 4HNO3 in the aqueous state, concentrated nitric acid is used here. This one gives you CvNO3 twice in the aqueous state plus 2NO2, it is gaseous form, plus 2H2 in the liquid state, water. Seventh equation. However, on reaction with dilute nitric acid, the product formed is nitric oxide gas. So 3C in the solid state plus 8HNO3 in the aqueous state dilute gives you 3CuNO3 twice in the aqueous state plus 2NO in the gaseous state plus H2O, 4H2O in the liquid state. Eighth equation. So this is what the writing the chemical equation. 6 steps are important. We have to use whatever we require while writing the chemical reactions. Friend, again here we are going to try one of the activity, and here the requirements are, that is the apparatus required, test tube, conical flask, balance, etc. And some chemicals that we required here are sodium chloride and silver nitrate. So friends, here you can see that we have to take sodium chloride solution on a conical flask and silver nitrate solution in a test tube. Tie a thread to the test tube and insert it carefully into the conical flask. You can see. Make the conical flask airtight by fitting a rubber cork. You can see here the rubber cork is there. Weigh the conical flask with the help of this balance weighing here. Now tilt the conical flask and mix the solution in the test tube with the sodium in the conical flask. You could see here. Weigh the conical flask again. Here again it is weighed. Which changes did you find? And any soluble substance form, was there any change in this weight? That we have to observe. From the figure we can see that some chemical changes are occurring over here. But what are the chemical changes? That we have to be see. Secondly, here we have to take the measurement actually. What are those? Friends, here we can imagine that which changes did you find? The first question's answer we'll try for this here. Which changes did you find? So a chemical change occurs and the solution in the conical flask changes to a white colored precipitate or suspension. Second question is, did my insoluble substances form? Yes, a white insoluble substance is formed in this. Third is, was there any change in the weight? Very nice question this one. No, there is no change in the weight of the conical flask before and after the reaction. So what inference one can be drawn here will be, this is because in any chemical reaction the total mass of each of the elements in the reactants is same as the total mass of each of the respective elements in the products. So this is in accordance with the law of conservation of mass. It is very important. So friends, here silver nitrate plus the sodium chloride in this gives you silver chloride plus sodium nitrate. The above word equation we can explain like this: AgNO3 in the aqueous state plus NaCl in the aqueous state gives you AgCl, that is white precipitate, plus NaNO3 in the aqueous state. So this is what the reaction that can be understood, that can be written over here. Here this is a reaction, this is a word reaction, and here it is a, you can say that a chemical reaction. Friends, here one thing we must know, that silver nitrate is used here in the water sink also. This is the use of this silver nitrate. Find out what are the other uses of this silver nitrate in everyday life. Friends, silver nitrate is used in developing of photographic films. This is one more application that is in the everyday life. It is used to treat wounds and burns on the skin due to the antiseptic property. It is used in making mirrors. In addition to this, it is also used in different explosives, which includes silver fulminate, silver acetaldehyde, and silver azide. These are the various applications of this silver nitrate. Friends, I think till that you come to know. Thank you to all of you for watching this video. We'll meet in the next video. Till that, bye.